Man, it's like every time you think you've got a handle on what's happening in the AI world, something new explodes onto the scene. Keeping up with all this can feel like a full-time job.
It really can, and I think that's why this deep dive we're doing today is so important. We're going to try to break down all the big stuff that came out of Nvidia's GTC conference. We've got all these announcements about their new chips and the whole ecosystem they're building.
Right, and there's a lot to cover.
Yeah.
But we want to make sure that everyone listening can really understand what all these advancements actually mean,
Mm,
you know, without drowning in a sea of jargon and technical details.
exactly, yeah. So I guess the best place to start might be with like the overall context. Think about the massive wave of AI development that's been happening, right? I mean, it seems like everything started to really accelerate with models like ChatGPT hitting the mainstream.
Totally. And NVIDIA is right at the heart of all that. In fact, the material we're looking at today says their sales have increased sixfold.
That's wild. It's not just growth, it's like a full-blown explosion, and it really shows you how crucial their technology is to just about everything happening in AI right now.
For sure. It's like a feedback loop, right?
Yeah.
All that demand fuels their innovation.
Yeah.
Speaking of which, let's talk about the big announcement, Blackwell Ultra.
Yeah. Jensen Huang, NVIDIA's CEO, he unveiled Blackwell Ultra at GTC. And what really struck me was how fast they're rolling it out. It's supposed to start shipping later this year, which seems incredibly fast.
Yeah, it does. Do you think that tells us something? Like, are they reacting to something?
It definitely suggests that they're moving super quickly to meet the demands of the AI world, which changes so fast. And there's a new thing, too. Huang was talking about something he called agentic AI. It's like AI that's not just crunching data, but can actually reason and plan and make its own decisions.
Agentic AI, huh?
Yeah.
So it's not just doing the same things faster, but it's like doing new things altogether.
Yeah.
So is Blackwell Ultra specifically designed to do that, this agentic AI?
Yes, exactly. Because those types of AI workloads, the reasoning and planning, they're way more demanding. So Blackwell Ultra is built to handle that, like from the ground up. It's got all the power and features to train and run AI models that are much more sophisticated, AI that can almost think like a human.
It's kind of a mind-blowing idea, right?
Yeah.
AI actually strategizing and solving problems independently.
Yeah.
I mean, that goes way beyond just recognizing patterns like what we've seen before.
Totally. And the potential upside for companies providing cloud services is insane. Our source says they could make up to 50 times more revenue with this compared to the older Hopper generation.
50 times. That's almost unbelievable. Why so much?
I think it just shows how much value the market puts on these advanced AI capabilities. Think about it. Cloud providers are all competing to offer the best AI services, so having something like Blackwell Ultra gives them a huge edge, allowing them to offer solutions that are way more powerful and sophisticated, and of course, they can charge a premium for that.
Now, I see there are two versions within Blackwell Ultra, the GB300 and the B300 GPU. What's the difference? Are they for different things?
Yeah. So think of the GB300 as a really tightly integrated unit. It combines NVIDIA's Blackwell GPU architecture with their own ARM CPU, all on a single platform that's super optimized. So it's really about maximum efficiency for specific heavy-duty AI tasks. The B300 is more like a standalone GPU, so it gives system builders more flexibility. They can pair it with different CPUs or integrate it into their existing setup.
Got it. So GB300 is like the all-in-one powerhouse, and B300 is more of a building block. And then the article talks about how these aren't just small-scale deployments either. We're talking server blades with 8 GPUs and racks with a crazy 72 Blackwell chips. The scale of these systems is mind-boggling.
It really is. It just shows the massive investment that's happening right now in building the infrastructure to run these next-generation AI models and how big companies are planning to deploy them. But get this. As amazing as Blackwell Ultra is, NVIDIA already gave us a sneak peek at something even further out, the Vera Rubin architecture.
Oh yeah, coming in the second half of 2026. I like that they named it after Vera Rubin, the astronomer who did all that work on dark matter. It's always cool to see those shout-outs to scientific pioneers. But Vera Rubin includes a new CPU, the Vera, and a new GPU, the Rubin. Why is the Vera CPU such a big deal?
Well, the big deal is that it's the first CPU that NVIDIA designed entirely from scratch, built on their own Olympus Core architecture. Before, they were using standard ARM designs for their CPUs. This is a whole new level of vertical integration, so now they have way more control over the whole system. And it should be a huge leap in performance. Our source says it'll be twice as fast as the CPUs in the Grace Blackwell chips.
Wow, double the performance. That's not just tweaking things, it's a total redesign. And the Rubin GPU itself, It sounds incredibly powerful, like 50 petaflops for inference, support for 288 GB of memory. Those numbers are almost impossible to grasp. How would you explain what that kind of power actually means?
I know, right? The numbers can seem abstract. Think about it like this. That much power means you can process much bigger and more complex AI models in real time. Things that take a long time to compute now, or are even impossible because of limitations, could become instantaneous. Imagine how much more responsive and capable AI applications could become. Also, with Rubin, they're moving to a multi-die GPU configuration, which is another big shift. It's basically combining multiple high-powered processors into one super powerful unit.
That's fascinating. It seems like Nvidia is actually changing how they define GPUs now, counting these multi-die chips as multiple GPUs.
Yeah.
They said Rubin Next, coming in late 2027, is a 4 GPU solution. So that's essentially doubling the performance of the single Rubin chip, right? They're getting creative about boosting performance, not just making individual chips bigger.
Exactly. It's like finding new ways to scale things up, and they're really moving fast with their whole roadmap. Think about it. Blackwell Ultra later this year, Vera Rubin in 2026, then Feynman already on the horizon for 2028. That's an annual release cycle. Before, it was every 2 years. It's a clear sign of how competitive and innovative this space is.
Absolutely. And it seems like the big players are really on board with this new generation of technology.
Oh, yeah, for sure. The article says that companies like Microsoft, Google, Amazon, they've already installed 3 times as many Blackwell chips as they had Hopper chips. That says a lot about how much they believe in these performance gains.
And those companies are definitely keeping a close eye on these announcements, figuring out if the upgrades in Blackwell Ultra and Vera Rubin are worth making even bigger investments in their data centers, all powered by Nvidia. There's a lot riding on this tech race.
Yeah, no doubt. And Nvidia isn't just focused on the chips themselves, they're building a whole ecosystem around their AI hardware.
True. We saw those announcements about AI-focused PCs like DGX Spark and DGX Station. I mean, having that kind of AI power right on your desktop, that's pretty wild.
Right. It could make AI development and research much more accessible. You wouldn't need access to these giant data centers to do serious work. And they're also working on new networking components, which are essential. I mean, when you have huge clusters of these GPUs working together, you need really fast, low latency communication between them. Otherwise, performance
Oh, yeah, for
suffers.
sure. And we can't forget about the Dynamo software either. It's not just about having the best hardware. You need good software to get the most out of it.
Exactly. Dynamo is all about helping developers fine-tune their AI workloads to squeeze every bit of performance out of these incredibly complex chips. And let's not forget the GTC conference itself. I mean, 25,000 attendees, hundreds of companies showing off what they've built using NVIDIA tech. It really is the center of the AI world.
Yeah. That partnership they announced with General Motors caught my eye. GM is using NVIDIA's services for their next-gen vehicles. It shows that this tech isn't just for cloud computing, it's spreading everywhere. Do you think that's a big deal?
I think it is. It means that people are recognizing that AI isn't just for software companies anymore. It's becoming a fundamental technology across all kinds of industries.
Hmm.
Think about cars. NVIDIA's tech can power everything from advanced driver assistance systems to fully autonomous driving, not to mention the AI experiences inside the car itself. This is just one example of how far-reaching these advancements are.
So if we were to summarize all this NVIDIA news, what are the main takeaways?
Well, the biggest thing is that innovation in AI hardware is speeding up like crazy. Blackwell Ultra is going to deliver a huge boost in computing power, specifically designed for more sophisticated agentic AI in the very near future. And then Vera Rubin gives us a glimpse of what's coming next, with another huge performance jump, and NVIDIA moving into custom CPU design.
It seems pretty clear that NVIDIA is more than just a part of the AI revolution. They're leading it, constantly pushing for more power and efficiency. Their influence on the future of AI across so many industries is undeniable.
It really is. And it leaves us with something to think about. With all this progress in AI computing, what completely new possibilities might emerge in the years to come? What challenges that seem impossible now might become solvable with these new technologies? It's a pretty exciting time, and there's so much potential.